Good afternoon, everybody. It is Andrew here for Central Illinois Weather, and we're going to be talking about potential for periods of strong to severe storms over the next few days. So yeah, it's been a while since we've done a forecasting video like this. If we go on to YouTube here, and kind of look. Oh, that's the wrong account. I don't know why it's set up for that account. Let me just go to YouTube.com. But you can kind of see we haven't really been uploading as much recently. I've done a few forecast videos here and there, mainly because I've been chasing recently. And currently, we are working on a documentary of my chase on Friday. It's gonna be kind of short. Wasn't anything big, but here's kind of the teaser for it. Working on the files, getting in there. We got some nice lightning. So yeah, let me change it over to that screen so you can see what it actually looks like right now. I guess the video editor will not show on here, but there are clips and stuff that I'm working on. But yeah, right now we're going to be talking about severe weather potential today over the plains, as we could have a significant severe weather day. There is a 5% tornado chance from the SBC, along with a 30 sig wind and a 30 sig hail over that general area. There is potential for some severe weather across western Illinois today as well, for my Illinois friends. It's not really going to affect our general area, though. As we get into the day 2 outlook, we have severe potential across multiple areas, one in the upper Midwest, and then one down here in the plains, and then one down here in the Ohio Valley. There could be some tornado activity down here. I would not be surprised if we get a 5% tornado risk tonight, with a slight in that area, and we'll go over more in a little bit. Day 3, there's severe weather potential in Iowa, Minnesota, Wisconsin, Nebraska, South Dakota. All hazards are possible. There is potentially an area for severe potential all the way into the Ohio Valley and Midwest that could be added eventually, but lack of deep layer shear and lack of confidence in storms developing is precluding that. Day 4, we have severe potential from Texas all the way up into Michigan. And this is where we could see a broad zone of severe weather. Hazards and everything are kind of uncertain at this point. We'll talk about it in a minute. The severe threat could extend more eastward as well. Could also extend kind of more northward. There's a lot of uncertainties with this. This is basically just a broad zone outlining it. We'll see with the next outlooks and get a more better idea. There's also potential for severe weather on days 5 and 6, but they just got removed from having a 15%. Here's a current look at your radar. We have a decaying MCS over northern Missouri and kind of southern Iowa there. And if we actually look over at the SBC site, they have a couple severe watches up. One that is across Kansas and Nebraska. This is where we could see a tornado or two tonight, and damaging wind gusts appear very likely across this area as well, along with large hail being likely. Probabilities, here you go, 60-60 hail, 70-60 wind, and 25 tornado. Severe thunderstorms are likely to develop early this evening and move from parts of western Kansas and southern Nebraska eastward into the central portions of Kansas. Large hail and severe gusts will be the primary hazard through mid-evening, with severe gusts becoming the main threat this evening. Looking at your current mixed layer cape, we can see we have values upwards of 2,000 or so right in the area where we have storms developing. There's a large area of thunderstorms, even thunderstorms over here today. If we go out all the way to the full Countess sector, we can kind of look at this. You can see here we have severe weather happening in central Wyoming. We have severe weather happening in western Nebraska. We have severe weather happening in northern Kansas and central Nebraska, and severe weather happening in northern Missouri. All more of a summer type setup again, like we've been having over the last few weeks. Looking at your 500 millibore, we can kind of see some bits and bobs of flow across this general region, providing enough deep layer shear for severe thunderstorm development. Looking at the 6 kilometer, we can definitely see there's spots where it's better than other spots. Kind of a large, broad zone. Severe storms are possible in areas where there's better forcing and more lifting mechanisms. Looking at your tornado ingredients, if we zoom back into the Central Plains here, we could see some tornadoes tonight. This risk is rather conditional. Let's look at our dew points here, and these are going to be expected to rise. We have a developing area of supercells in north central Nebraska. This is expected to come into an MCS cluster and dive southward. There's dew points in the middle 60s where we could see some sort of severe or some sort of a more elevated tornado risk over here. This area has had convection all day. And then looking at the hodograph map Cameron Nixon made, you can see there's hodographs favorable for tornadoes kind of in this general region and over here along the warm front. This is probably where we're going to see tornado potential tonight. Once that MCS kind of collides in that area, we could see some tornado potential. Looking at the enhanced stretching, this is where maybe some land spouts are going to be possible. Colorado could have a land spout or two, and then also South Dakota, and maybe Wyoming as well. Here's a look at 3 Cape, so 3 Cape and vorticity. Let's get that up. There you go. This squall ended up having a lot of 3 Cape and vorticity over here. There was some activity with it. There's not much 3 Cape in Nebraska right now, but there's enough to get the job done, and especially with it being a QLCS setup, you don't need as much lower level instability. These storms are relying off a lot of vorticity, which is why land spouts are going to be possible. Looking into the Weather Prediction Center over the next few days, just kind of what the frontal look's going to look like. You're going to see some storms kind of riding up front. Some strong storms are possible all the way into Illinois tonight. 18Z tomorrow, we could see some stronger storms all the way from kind of Tennessee, Kentucky into Illinois. There's potential for that. 0Z, mainly a Kentucky issue there, as rain is likely there. 12Z Friday, and then Thursday, there could be severe potential from Illinois, maybe Illinois, but mainly Iowa, Nebraska, South Dakota, North Dakota, Minnesota, and Wisconsin, as that kind of more force mechanism is going to be over there. Friday, this is when severe potential is going to be possible from the plains all the way up to the Midwest, maybe some morning thunderstorms. We're going to talk about the details of Friday in a bit. Saturday, severe weather is possible, and Sunday, severe weather is possible as well. Let's go out and look at the GFS really quickly here. I'll kind of go over some things over the next few days. So here's kind of your look right now. Here's a look at tomorrow, and actually we're gonna look at the NAM. We're gonna look at the RAF first. Sorry for jumping around at models, but here's a look at tomorrow. There's gonna be a forcing mechanism down in Kentucky, Illinois region, down there in the Ohio Valley that will bring severe potential to be more possible across that area. You're also going to see enough instability where you could see some strong to severe storms as well, and there's going to be enough lower level instability as well. And if we zoom in here, we can kind of look and see there's going to be tornado potential with this area, and that's where the SPC outlined a 2% area. Strong dew points as well across the region. 850 millibar shear is there. It kind of goes along with it. It's going to be a decaying MCS that may put out an MCV. We'll have to watch it closely. There will be some subsidence, but that will probably more or less happen in Illinois and Missouri. That's why their risk is going to be highest at 20Z or so. But the thing about that is there's not much convection. There is enough, though. If we do take soundings in front of this convection, this will be a sounding near Bloomington, Illinois, and then we can take a sounding not too far from Bowling Green, Kentucky here. So this will have, if this were to be true, we would have tornado potential and wind gust potential into Illinois, along as large hail potential. Here is a look at Kentucky. You have a larger low-level hodograph, and you already have probably sustained convection ongoing at this point. There is a bit of a stable layer, though, at around 700 to 850 millibars, which is causing there to be some SYNH, which could be a problem. We'll really have to see where these storms kind of develop, and if they ride different mechanisms and boundaries and stuff. Here's going to be a sounding closer to the end general activity. And this is a little bit contaminated, but this is going to give you a more near storm environment. Let me go back a frame and get you a better sounding, kind of in that area where we're watching for maybe some isolated tornado potential. There we go. So there is an inversion still here, but this will definitely be favorable for some tornadoes. We're going to see large hail definitely be a possibility. Your thermodynamic profile is pretty big, especially in the middle upper levels there. Damaging wind gusts are possible, as well as you have not really an inverted V profile in the low levels, but there is enough dry air for that to be possible, and all the hazards. You also have enough deep layer shear, and there's enough decape. Now, I do not think storms will be outflow dominant unless they end up going upscale, and even then, you'll probably have tornado potential because you don't have so much decape. Your mixed layer instability is pretty high as well. As we move along here, we can see severe potential up into the upper Midwest. We'll take a look at that. And there's also severe potential all the way out into southwest Kansas there, southeast Colorado. This is a look at the upper Midwest. It's a little bit contaminated, but, or not a little bit, a good amount contaminated, but you can see here a very crosswise profile shown here in the photograph. There's not much turning with height, really at all, but you have enough instability and you have enough wind shear to where you could have damaging wind gusts and large hail, especially large hail with these long, straight photographs like this. This definitely favors large hail. Damaging wind gusts are maybe possible, but not much decape to really get stronger winds, so you could have an isolated severe gust, but nothing too significant out here in the plains. Let's take a forecast sounding at 0Z there. This is where we're going to have outflow dominant supercells possible with probably some good structure, as this photograph demonstrates there. Drier surface conditions there. Good mid-level shear up at around 6 to 9 kilometers. Strong decape. This favors more of a damaging wind risk. Large hail will be possible, though, given the fact that you do have large, very steep lapse rates there and a pretty good thermodynamic profile. It's just going to depend how dry the surface is for that, but I do think large hail is going to be a possibility. So overall, some mesoscale kind of areas to watch. Let's look at the NAM, and let's go out here. There is severe potential Friday as well, across the upper Midwest there. Let's look at that really quickly in the northern plains. We have a warm front here that's going to be stationed across kind of this general area. And then we have warm air. Let me get a different color. We have warm air kind of moving upward into this general region. And then we have a low pressure system kind of centered right there or so. And we have a cold front behind that. And so that's going to cause forcing for strong storms to be possible, along with the vorticity max as well, kind of being around this general area. A little bit better 3 cape and vorticity as you get earlier in the day, and this would be your target area, would be south central Minnesota if this was to be true. Let's take a sounding in that vorticity 3 cape max. Let's kind of take a look at it. And yeah, that is a solid tornado potential sounding. Now, one thing about it that would maybe limit tornado potential is your winds not really curving until you get to the lowest kilometer. This is going to favor a lot of large hail, though, for sure, given the photograph shape. You have some curviness in the lower levels, but really, once you get up in the height, this is very favorable. Very straight photograph, more favorable for large hail. Isolated damaging winds are going to be possible with some of this convection initially, but mainly large hail, maybe very large hail, upwards of 2 inches or a little bit greater, and then tornadoes will be possible initially with this convection. Now, as we move ahead there, we're going to see the tornado threat's probably going to be maximized from, this would be 3 o'clock to probably 6 or so. It's going to be a short window of severe potential, or tornado potential, sorry. before there's more of a linear mode and the instability in the lowest levels is a little bit weaker. We can also see kind of this general area of convection forming there. We take soundings in front of it. We can kind of see that this is going to favor more of a damaging wind risk, given the fact that you have lower amounts of, or given the fact that you have like a higher dew point depression there, and also that you have a more inverted V profile. There's also a bit of a stable layer, along with maybe a small surface inversion that will also hinder the potential for tornadoes, unless we get an organized like supercell to still be continuing at this point, or we have an organized linear segment. So I'd say the tornado potential isn't really conditional, but it's more of a short window. Large scale damaging wind gusts will be possible pretty much throughout the night. Looking into more of the ingredients here, the lapse rates are going to be pretty high. Earlier in the day, they're going to be better in the lower levels, as you can see here, kind of around 22, 21Z. Middle level lapse rates are going to be pretty good throughout the day. Your Mixler Cape, it's going to uncap very quickly, and then we'll get some storm initiation when that happens, and then stay capped. Looking at your MU Cape, we can see there's definitely going to be more than enough there. Now let me look at something kind of the boundary motion and to see like where. So your general flow is moving kind of this way at around 50, 60 knots east, with maybe a hinge north. So let's go to your dew points and kind of look at this, our theta E axis, and kind of look at this. So this is going to favor, given the fact that you have a large given the fact that you have the storm motions kind of like that, they have the storm motions more east northeast, kind of like this. That's going to be able to glide across the instability axis, which will make it easier for tornado potential to be possible, given the fact that that is happening. Now, also you're going to have more potential for kind of those storms to stay more long-lived as well, given the fact that they're not going to be overrunning the instability axis up here as well. So I feel like this is going to be this could be a pretty decently long-lived event as well, whether it's supercells or an MCS. Now, looking at the NAM, it's showing something pretty similar actually to the RAP. You have again a little bit more uncapped than the RAP is. We also have potential for warm front storms as well, into kind of the Ohio Valley. That risk is very conditional, and it's going to rely on kind of surface observations to really see. And actually, it's more of a secondary. Warm front. This is the main warm front all the way over here. That's not a good color. The main warm front's kind of all the way over here, but we have another secondary, maybe instability gradient in here where there's a stronger theta E axis. We could see something try to develop in, let's see where the 500 flow motions are. Storm motions. We could have something try to develop there. Well, no. There is subsidence there, so it will create a little bit harder of a time for storms to form. And subsidence is basically the main region of the jet kind of getting out of the region before storms fire, or could fire. This won't say storms won't fire, but it's going to make it harder. Missouri might have a chance of firing if the NAM was to be correct there. Looking at your most unstable cape kind of shows you the general region here, and there's going to be enough instability for generally all hazards up in here. Let's kind of look and see what a sounding is going to be like up in that general region up there. And again, pretty similar to the NAM, except we have a pretty big surface inversion. Pretty similar to the RAP, except we have a bigger surface inversion there. Kind of look and see. You can definitely pick out the boundaries with this. We have a boundary right here, and that's the warm front, and then we have a secondary kind of boundary generally right here. Maybe something else here along the mountain ranges. So there's going to be areas where you could see storms fire a little bit easier. And this is going to be a mesoscale forecast to see where they end up setting up. And there's your cold front crashing. Now let's get into Friday's risk. Friday is going to have a severe risk from the southern plains all the way into the Midwest, stretching along a couple areas of forcing here. Let's go look at your theta E axis. So we have a cold front. We have a main low pressure system up in Canada right there. This is going to have a huge cold front sparking down with it, along with a big change in temperatures as well. And then once you get into Oklahoma, Texas region, we have another low pressure system hanging out. Looks like maybe right here. Oh, this one might be another one up in the Rockies as well. And that's going to have a transition where you have a little bit of a stationary front, and then we get a little bit of a dry line going down there. And a dry line is going to move a lot, and usually moves more slower than a cold front. Doesn't usually move slower, but a dry line is different because you have drier air and the temperatures don't really change behind it. Now the NAM caps everything to all heck, which is a possibility, but I'm not really seeing it at this time. All the global models don't have that. Right along the front, though, in Oklahoma, it uncaps it. And here's a look at your bulk shear. This is a new parameter added on College Dew page, and the area it uncaps, it's going to be favorable for wind and hail, definitely. That's a new parameter here. This is generally your bulk shear, so you can see areas highlighted in those yellows, reds, and purples are going to be areas where you're going to watch for storms. And let's sorry about that. Let's get our little pen out here and let's kind of mark these areas that have instability in this kind of general color right here, and let's kind of see where they overlap with the 500 millibar axis. And these are going to be areas that could see severe potential depending upon the frontal position. Based off the NAM run, this area would see it. Let's look at 500 millibar and see what we have, or the new parameter they added. So, looking at that new parameter, we can see main areas that have more shear is going to be kind of right along that dry line intersection. Kind of right in here is really the area that has more shear, and that's right along the front. So you're going to have storm initiation probably right along the front. If we do look at how the NAM is convecting this, we can see the NAM generally has the bigger stuff up in Canada, and there's going to be severe potential into Canada with this. And that's probably where your higher tornado risk is going to be. It's probably going to be right here. You're going to have a higher tornado risk. Maybe the dry line has a decent tornado risk too. Let's take a look. Let's take an in-depth look at that. And no, not really. You don't have enough low-level spin there. Maybe along the frontal boundary intersection, but generally it doesn't look like it. And okay, that would definitely favor more of a tornado threat. You have a lot more back winds at the surface. As well as you have a lot more upper level and middle level flow. Your hodograph is a little bit wonky once you get to the upper levels, but that's typical for events like this where you have that cold front kind of, or not really cold front, but where you have kind of upper level flow. You have a little bit of veer back veer is what that's called, right around, I believe that's 9 kilometers or so. Where it veers back into the hodograph. This can cause more splitting storms, but upper level veer back veer isn't necessarily a bad thing, usually. Some setups it can be, though. Looking at 850 millibar winds, we can see we have a decent area of 850 millibar winds kind of spreading across the region. And then we have a lot of 500 millibar as well. This is basically your wind shear up in height. Let's look at the GFS now. This will give us another idea of kind of where we're at. So the GFS is a lot different from the NAM. The NAM has it oriented a lot different, and whoops. The NAM has it oriented a lot different. I am not meaning to. There we go. So the NAM has it a lot oriented a lot more different than the GFS does. If we go over to 500, we can kind of see The GFS and NAM have a lot of differences. NAM would favor more of a good setup across Oklahoma, Texas, while the GFS favors a pretty good setup from Canada into the Midwest there. All hazards are going to be possible in Canada and Michigan, I feel like, as those areas are going to have a better chance of more backwinds. Now, looks like they're more veered here, mainly making Canada the main risk. But that surface low in Oklahoma will probably help out backing the winds and creating higher tornado potential in a local area, maybe around the Red River region. But generally, we are expecting a large line of storms to form with damaging wind and hail potential. Now let's dive into this risk more for the Midwest here. So, looking at the GFS, let's take some soundings here. That's a sounding east of St. Louis. So there's a pretty good stable layer and inversion around, what was that, 700 millibars. Now, there's going to be a pretty good cap most of the day across the Midwest, which will probably negate severe potential until later in the day, unless we get storms to fire over the cap. And so also generally make it so you're going to have more of a wind risk more than anything. Wind and hail. Probably more hail related risk. And I think hail is probably going to be the main threat if the storms are not surface-based, like some of the models are showing. Now 21Z, we might see brief surface-based activity across kind of the Michigan region as the cap breaks there. Really depends where the cap breaks. It's going to be conditional setup. We're really going to have to watch kind of see where the cap breaks. And yeah, there you go. The cap broke there. There's still a stable layer, but kind of power through. But storms will probably still be able to form there. There's a lot of instability within the middle upper levels there. Here's where your instability is generally located, kind of right there. So that's where your severe potential will be possible. Or not severe potential. That's where your instability is going to be. That's a pretty good instability profile. 2,500 mixed layer cape is not bad. Now, if we go to the surface-based or mixed layer parcel, most unstable parcel, it's going to look a little bit different. Here's a look at the most unstable parcel, and if we look at the most unstable parcel, we can see that the instability is a lot greater there, and this would probably cause storms to form. Michigan earlier because of the most unstable parcel being not so capped. Now the GFS is also probably the fastest out of these models with the front. It has the front moving very fast. And the mixed layer is going to be pretty capped, but the most unstable layer is not going to be so, well, it's actually still pretty bad in this sounding at least. There's not much, there's not much more instability, but the thing about this is if we have enough forcing to break through the cap, which is very much possible given the fact that we have a cold front here, we'll probably still see storms because we still have pretty strong shear throughout the atmosphere there. You can see kind of the general area with the shear and the instability overlap right there. So yeah, looking at the SREF, which is another tool we look at, we can see it generally has a similar solution, maybe like GFS or NAM. Lots of instability being present as well. A lot more uncertain how fast this cold front crashes. There's a lot of uncertainty with that. The mean has it crashing earlier. There's a lot of disagreement also on where the lows are going to be placed. This low is a little bit further east. There's some that have it here. Kind of the mean placements of it. One here, and then one there. So there's going to be possibilities there of where the low could be. And we're going to go into Sharpie and look at the potential soundings that we could see. Kind of the mean soundings, basically the mean soundings on Sharpie. So let's go to Oklahoma. We'll take a look at one there. We'll go to Fort Still. Not sure why it's not working. There we go. So we're gonna get a sounding here in a second, and this is I was looking at these earlier. I probably should have gone a little bit more in depth on what a sounding is generally for the public. But a sounding is basically what you have instability wise, wind shear wise, pretty much everything you need for pretty much everything you need for weather in general is within a sounding. Not everything, but a lot of things are within it. You have your temperature, your dew point, you have how strong the winds are with height, you have kind of those general values, and there we go. So the SRF here, a lot of disagreement. You have strong instability there from about 3 kilometers to 12 kilometers, as you can see here. But there is a pretty big stable layer within the low levels there, as well. Which that's going to be something interesting. Kind of watch and see what happens with. There's a lot. The SRF is not really confident with there being not as much of a cap. We can look around early evening in central Illinois near Blooming. We'll look near kind of Decatur. And kind of see what it looks like there. So, looking at the Decatur region here, we can see that that whole time it has not. We can see that based off this, there is a pretty strong cap within the low levels, but with height, it does end up being a lot weaker, and we probably would get storms of something like this. Now that is going to do it for this one. A bit longer of a video than I wanted to, but that's your forecast breakdown for today, May 17th. If you have any questions, leave them down in the comments, and I will try to answer them. I've been really busy with school recently, so I really haven't had the chance to upload, but today I had the chance to. Maybe more in the future, not maybe, but more in the future we'll have stuff like this, but that's going to do it for this one.